Okay, so let's continue with this. Let me share my screen. Now, generally talking, we know what confidence interval is, right? A confidence interval is basically a range of values somewhere in between your true value exists. Like, let's just say that the confidence interval that we chose right now is 95%. Okay? So I am saying to you that the that I am 95% confident that the true value of blood pressure that I mentioned that I calculate sorry that I checked for a patient lies between 80 mm of Hg and 140 mm of Hg. So the confidence interval here is from 80 to 140. So, and no, it's not sharing right now. I'm asking something. And for another patient, I say that I'm 95% confident that the true value of the blood pressure that I found for this patient lies between 110 mm of Hg and 120 mm of Hg. So, which calculation is more precise, in your opinion? It's okay, guys. You can
Uh,
ask me to read the
Maybe
question.
maybe 110 to 120.
Exactly, exactly. Why? Because it's a smaller range. And the confidence interval is not wider. What do we mean by a wide confidence interval? There is a huge gap between the two values. And what does the huge gap mean? It means that the true value can be anywhere between these two extremes. So if I'm saying from 80 to 140, it could be 85, it could be 90. We do not know. So a wider confidence interval means less precision, and a narrower confidence interval means more precision. Is this point clear?
Yes,
I'll
ma'am.
show you guys on the forest plot as well, but I need to explain this point to, make you guys understand about the weightage. So for the weight, studies with a higher population size and with more precision, and this precision is based entirely on the confidence interval, have higher weightage. No, it's not proportional. Sometimes a higher population has a wider confidence interval. Sometimes. It's not something that you can, correlate. It depends entirely on the study. Let me show you guys. What I was saying is that the weightage depends directly on the size of the population and the confidence interval. Higher population size, bigger box, more weightage. Narrower confidence interval, bigger box, more weightage. So the confidence interval is inversely proportional with the weightage, and the size of population is directly proportional. Let me show you guys. See, for this one, most of these are roughly the same. It's from 3.11 to 5.69. It's a very narrow confidence interval, like from 3 to basically 6 or 5.5. This one is from minus 1.22 to 15.96. Now, this is a wider one. But why is the box bigger? Let's see. Let's see the population size. See, total 84, total 62. 84 plus 62 is the population size for this study. What is it for the other studies? It's way lesser. 33 and 66, 24 and 30, 20 and 20. That's why. And for this study, the confidence interval is greater, but it also has a higher population. That's why the sizes of the boxes are almost the same. Almost. Why? Because for the studies which have a lower and a narrower confidence interval, the population size is small as well. And for the studies which are having a higher population size in this particular forest part, the confidence interval is wider. That's why the sizes of the boxes are almost the same. Is the point about confidence and sorry about weightage clear?
Yes, ma'am.
Okay, awesome. Let's move on to the next point. Okay, we're talking about diamond in the forest plot. In a forest plot, the diamond represents the overall pooled estimate of effect size from all the studies combined. See, this is the box for this study. This is the estimate for this study. This is for this one. Same goes for all of them. Now, this diamond is basically a pooled estimate. You pool all of this data from these individual studies and you combine it. The software combines it and it gives you this diamond, right? We call this diamond because it's diamond shaped. Not really, but we call it that. Center of the diamond shows the point estimate of the overall effect, like combined risk ratio, odds ratio, or mean difference. And the width of the diamond shows the confidence interval. Let's talk about this. Okay, we're zooming in. Now, draw a horizontal imaginary line and a vertical imaginary line, and that combines, sorry, that crosses at this center point. Okay. So this is the point estimate. This center of the diamond represents the point estimate. What do we mean by that? Let's see. Now for the mean difference, we have the point estimate, the value of mean difference, and we have the confidence interval. See, from 9.2 to 66.07. And the point estimate is 37.63. Now look at this graph. See, this is 0, this is 50, this is 100. So this must be 10, 20, 30, 40. 40 will be somewhere over here. This will be almost 30. Now look at the point estimate, the center point. Corresponded over here. See, it is almost nearer to 40, but it is between 30 and 40. You cannot see 30, 40 written here, but imaginary 1, 10, 20, 30, and 40. So it's nearer to 40 and it is away from 30. So what is the value? 37.63. This value comes from here, from the center of the diamond, and we correspond it with the x-axis. Is that clear? Okay. Now this is the center, but these two ends, they represent the confidence interval. Now what did we say? We said that the wider the diamond, the narrower the confidence interval. I'm sorry guys, give me a second. Let me plug in my laptop. Okay, sorry about that. Let's move on. We were saying that the wider the diamond, the wider the diamond, the more the confidence interval. Wider diamond, wider confidence interval. Narrower diamond means narrower confidence interval. And how do we determine that? Look at the pointy ends of the diamond in the horizontal plane, not the vertical one. Um, Look at this end. What does it correspond to? It corresponds to almost roughly 10. Now see the value of confidence interval 9.2, almost 10. And look at this one 60, 70. It is lying between 60 and 70. This line, if you correspond it with the x-axis, what is the value? 66.07. This is a very wide confidence interval. So the very wide confidence interval means that the results are not precise. Okay? So is point estimate and confidence interval clear?
Yes,
Any question?
ma'am.
Okay, okay. So let's go on. Now let's talk about line of no effect. For understanding the line of no effect, we'll talk about risk ratio and mean difference. So, can someone tell me what do you what can you tell about risk ratio by just, hearing the word risk ratio? Is it a ratio? Do we divide two values? Do we add two values? What do we do? Risks of two groups which are comparable. Yes. But what do we do? Do we add those two values? Do we divide them? Just look at the name risk ratio. Yes, we divide them. Now, if we divide two values which are equal, what do we get? One, yes. And for continuous outcome, sorry, for dichotomous outcome, which effect measure do we use? Risk ratio or mean difference? Risk ratio. Excellent. Now let's look at the forest plot for for the dichotomous outcome. Okay. See, now see the midpoint. This middle line is called line of no effect. Why is it called line of no effect? It's called line of no effect because when the risk ratio is equal to 1, bilkul, sorry, exactly 1. When it's exactly 1, that means that the risk in the control group and the intervention group is the same. Same for both. Now, if it's same, we get 1, right? Because we divide it. I'll even show you guys the formula for risk ratio. It's very easy. Not really something that we should concern ourselves with, but it's better to understand it properly. So that's why for risk ratio, the line of no effect is 1. Why? Because if both the intervention and the control groups are truly exactly equal, we'll get 1. Is this point clear?
Yes, ma'am.
Okay. Now for mean difference. What can you tell by mean about mean difference from the word mean difference? Addition, subtraction, what?
Total of all the means divided by the total number of study.
Sorry?
Total of all the means, the mean, we're talking about the mean difference, so it's the total of all the means.
No, it's not. Let me tell you the formula as well. So for finding mean difference, yes, not between highest and lowest value, it's the difference between the intervention, the mean of the intervention group and the mean of the control group. Intervention minus control. So if both of those values are equal, what will you get? 1 or 0? 0, exactly.
Yeah.
Yes, that's why for continuous outcomes, the line of no effect is at 0. For dichotomous, it's at 1 because it's a ratio. And for ratios, when you take two equal values, you get 1. And for continuous outcomes, as it's a difference, you subtract two values. If you subtract two equal values, you'll get 0. That's why for um, dichotomous outcomes, line of no effect, the central line is at 0. Okay. Line of no effect for risk ratio. Odds ratio is not something we should worry about. Just let it be. You did see the option in Revman, but it's not something we use. So for risk ratio, the no effect line is at 1. For mean difference, it's at 0. If the diamond does not touch the line, the overall result is statistically significant. If it crosses, not statistically significant. Let's talk about that. See, for this one, this is the line of no effect. The diamond, as you can see, is not touching the line. And for the value of P, you can see that it's a significant value. How do we tell if it's significant? If the value of P is lesser than 0.05, I'll repeat it again. If the value of P is lesser than 0.05, that means your results are significant. If the value of P is greater than 0.05, your results are not significant. You can see we mentioned that if the diamond is touching the line, the results will be insignificant. If it's not touching the line, the results will be significant. Let's see it for this one. The diamond is touching the line. Look at the value of P over here. It's insignificant, non-significant. Is this clear?
Yes, ma'am.
Okay. So if touches the line or matter, obviously it's not irrelevant. Why would it be irrelevant? If you are conducting a research properly, you're carrying out the analysis properly, it is a finding. Even not finding anything is a finding over here. Why? Because you're essentially proving that the intervention and the control group is the same. You are giving the knowledge to them, which is based on statistical and analytical evidence. It's not irrelevant, it's highly relevant. I hope that clears things up. Okay. So we already discussed confidence interval, but let's go over it again. A confidence interval is a range of values that is used to estimate an unknown population parameter like a mean, proportion, odds or risk ratio with a certain level of confidence. The certain level of confidence that we used when we were carrying out our analysis was 95% confidence interval. You guys do remember it, right? Okay, so the example is that suppose a study finds that a new drug reduces blood pressure by an average of 5 mmHg with a 95% of confidence interval of 2 to 8 mm of Hg. This means we are 95% confident that the true average reduction in the population is between 2 and 8 mm of Hg. All right, we already discussed this example. width of the confidence interval. A narrow CI means more precision and a wide CI means more uncertainty. Wider CI means less precision. Level of confidence, we usually use 95%, but 90 and 99% are also used, but we always stick to 95%. For significance, if the confidence interval for a mean difference does not include 0, or the confidence interval for an odds ratio or risk ratio does not include 1, the result is usually statistically significant. Okay, let's talk about this as well. These results were statistically significant, right? Look at the confidence interval. Now, this is a continuous outcome, and the line of no effect is obviously at 0. So for a continuous outcome, if the confidence interval does not include 0, like 0 does not come between the confidence interval. If, for example, the value was minus 3.4 to 15.6, the 0 does lie between these two values, right? Then the result would be most probably insignificant. Most probably. It's not must, but there is like a 95% chance that it is insignificant. This is for mean difference. For for dichotomous outcomes, let's see. Line of no effect is obviously at 0. So if one lies in between the confidence interval, then your results will most probably be insignificant. So look at this one, 0.65 to 1.07. So one does come in between. That's why this result is insignificant. Okay. Over here. Is this point clear? If it touches, some outcome would always be touching the line, right? Yes. Most of the outcomes usually I've observed are insignificant. You're lucky if you find some significant findings. Is this point clear? The one about 0 and 1 and the confidence interval? Yes.
Ma'am,
Okay.
can you just repeat again? Just once.
Obviously, I can. I'd love
Mhm.
to. Okay. So let's see again. This is a continuous outcome, right? The forest plot for a continuous outcome. Now, the line of no effect for a continuous outcome is always at 0. Okay. And the confidence interval for this outcome. We mentioned before that if the diamond is touching the central line, that means that the findings are going to be insignificant. Okay. So generally, just by looking at this forest plot, I can see that the diamond is not touching the 0 line. So I'll assume, without looking at any of the statistics given, that there is a very high chance that this result is significant. Why? Because the diamond is not touching the line of no effect. So the line of no effect in case of continuous outcome, it is 0. But what I will do is that I'll look at these two things first. I'll visually look at whether the line is touching the diamond or not. Then what I'll do is that I'll look at the confidence interval as well. So tell me one thing. You can unmute yourself. Um, 9.20 is the initial, extreme, and 66.07 is the other extreme for the confidence interval. The range is given. So does 0, which is, the no effect measure, lie between 9.2 and 66.07? Does it?
No.
No, it does not. So that means that the line of no effect was not traversed by this diamond. Okay. Now, for example, if the confidence interval was -50 and +10, the diamond would be from here to here. This would be the length of the diamond. And this diamond would be touching the line of no effect. And in this scenario, our results would be insignificant. So what we have to do is that we look at the confidence interval. We see that for continuous outcome, if the confidence interval has zero somewhere in between, then the results will most probably be non-significant. And for dichotomous outcomes, it's the same. But here the line of no effect is 1. Now look at this forest plot. The diamond is touching the midline, right? And look at the confidence interval now. It's 0.65 to 1.07. Now for dichotomous outcomes, line of no effect is 1, right? Does this confidence interval have 1 in between the two values?
Yes.
Yes. So if for dichotomous outcomes, the um, the diamond is touching the midline and the confidence interval has 1 in between, the results will be insignificant. The p-value, you will look at the value of p. Is it less than 0.05? If yes, then the results are significant. If not, then the results are insignificant. So here it's greater than 0.05, it's 0.15. The results are not significant. That's how you can tell. Should we move on?
Yes, ma'am. Yes, ma'am. Thank you. Thank you so much.
Okay. No problem. Okay. Now, another interesting thing. See, do you guys see these green boxes, right? And you see that there is a line over here. Interesting thing is that the length of this line corresponds to the confidence interval of the individual study. See this one? The confidence interval for this is 32.9 to 48.28. Let's 1 to 10, 20, 30, 40. Corresponds over here and almost near to 50. And see the numbers 32.9 to 48.28 over here and over here. So the length of this line tells you about the confidence interval of this study, individual studies. Another thing, we did say that the wider the diamond, the more the confidence interval, the lesser the precision, right? Same goes for these one. The longer this line, the wider the confidence interval, the lesser the precision. Is this point clear?
Yes, ma'am.
Excellent. Okay. Now let's talk about risk ratio and mean difference. Now, risk ratio compares the probability of an event happening in two groups. It is used for binary outcomes, for example, disease versus no disease, disease versus survival. Like if you are assessing how many people in a given population had malaria, so obviously there will be two groups of patients, patients with malaria, patients without malaria, two possibilities. So that's a binary variable. Same goes for death versus survival, mortality. So risk ratio is used for binary outcomes. Like let's just take an example. In a trial, 10% of patients die with drug A and 20% patients die with placebo. So, how do we calculate the risk ratio? We calculate it by risk in treatment group divided by risk in control group. So in treatment group, it was 10%, so 0.10. And in the control group, it was 20%, so 0.20. Now you divide these two and you get 0.5. So how do you interpret the value of this ratio? We do it by comparing it with the line of no effect. So line of no effect for risk ratio is 1, right? So if risk ratio is equal to 1, that means that the risk in the treatment and the control group was the same. So you will get 1. That means there was no effect. And let's just say that risk ratio is less than 1. That means, sorry, yes, risk ratio is less than 1. That means treatment reduces the risk. Let's see in the forest plot. So if this side is for the experimental group and this side is for the control group, right? This is the treatment group and this is the control group. Here the values are less than 1 and here the values are greater than 1. Now, if the risk ratio is less than 1, that means that the diamond is on this side, on the side of the experimental group. And if the diamond is on this side, that means that the pooled data is on the side of the control group. Okay? So if the diamond is on this side, that means that the treatment group has better results and the risk ratio favors the treatment group. Okay? And if the diamond is on this side, which is greater than 1, that means that the risk ratio favors the control group. On this side, treatment reduces the risk. If the diamond is on this side, what do we interpret? We interpret that the treatment reduces the risk of whatever the outcome is. Let's just say it's um progression, sorry. Let's just say it's nausea and vomiting, incidence of nausea and vomiting in patients. Now, if the diamond is on this side less than 1, that means that with the treatment group, patients faced lesser complications involving nausea and vomiting. If the diamond is on the control group side, then we say that patients in the control group had lesser complications of nausea and vomiting in comparison to the treatment group. All right. And what will happen in this case? That means that the treatment group is not the good option here. It has higher incidence of the said complication. Is this point clear, guys?
Yes, ma'am.
I think we had to remove a. No, not really. Can't really do anything about that. Even if you add that study, first of all, your results will be wrong. Secondly, you will have a very high heterogeneity. So we'll discuss heterogeneity as well, but a very high heterogeneity is very bad. It's not good. That means that your results are not reliable. So you can't really do anything about it. Okay, let's go back. So I hope risk ratio is clear. Let's go towards mean difference. So mean difference is used for continuous outcomes. For example, blood pressure, weight, score of something, and it shows the difference in average values between two groups. Like for example, average BP with drug A is 120 mm of Hg. Average BP with placebo is 130 mm of Hg. Now in mean difference, what do you do is that you take the mean of the intervention minus mean of the control and you get your mean difference. So in this case, it's minus 10 mm of Hg. So we interpret it the same as we interpret risk ratio. But here, mean difference, if it's equal to 0, that means there is no difference between the two groups. And if mean difference is not equal to 0, that means that either the intervention group is superior or the control group is superior. Depends totally on the position of the diamond. The horizontal line might be centered at 1 for risk ratio or odds ratio, line of no effect. For mean difference, the line of no effect is at 0. No difference. So is risk ratio and mean difference clear?
Yes, ma'am. It's good.
Okay. Um, are you guys okay with continuing right now? Or should we continue in the next session?
Yes, ma'am. You can continue, ma'am.
Excellent.
It's very interesting, like the way you're explaining. It's like it's very in depth, and it's very engaging. It's very interesting, ma'am.
Thank you. I'm just hoping that you guys understand. It will be more interesting when you download RevMan and you do it yourself. If you want a data set, like an extraction sheet which is completed, I'll send it to Laiba and she can, or I'll send it in the group. I'm added to the group as well. Okay. So then we talk about the p-value. So as I showed you guys the p-value, and I said that this is the most important part, the most important value, the value of p, which shows whether your results are significant or not significant. So let's talk about it. How do we interpret it? What does it mean? Okay. P-value actually tells us if we can reject the null hypothesis or not. Null hypothesis tells us if the results were due to chance or are actually statistically relevant to the variables we are studying. Now, let's talk about this. Let's say that we are testing drug A versus drug B, and we find that incidence of, the length of hospital stay was very low with drug A in comparison to drug B. Now, if you don't analyze it, you'll just say that, oh, by first look, based on your first judgment, you'll say that drug A is better than drug B. But there's a high possibility that the lesser value of hospital stay with drug A was totally based on chance. Like it was not something that was, based on the positive effects of drug A. It was totally due to chance. So that's possible. So the purpose of carrying out the analysis is finding out whether the superiority of one treatment option or one surgical treatment option was based on chance alone, or is it actually the better and the superior treatment option? So what do we do is, if the value of P is greater than 0.05, we cannot reject the null hypothesis and results are statistically insignificant. Now, what is the null hypothesis? Null hypothesis is that you hypothesize that the outcome and the intervention or the control is not relevant to that the outcome is not relevant with the choice of intervention or control, and it is based on chance alone. Okay, the meeting is about to end.